Geometry 1, Chapter 2, Topic 6. Know the postulates on page 84 of your textbook. Now, the best thing probably to do with these postulates is to just make some flashcards and memorize them. So, complete each of the following statements. And we're just going to do 3 of the postulates. Please refer to your book to see all of them and memorize them. So the first one, through any 2 points there exists. So what I find to be helpful is to draw a picture. Here are 2 points. Now, given that this is a geometry class, when you have 2 points, there are a couple of logical things to do, but what I find tempting is to connect them, to draw a line. But notice, there's actually only one line that can be drawn through those 2 points. And the question always becomes, well, does it have to be a straight line? Can I draw a curved line? Well, if you listen to that statement, can you draw a curved line? A curved line's not a line, it's a curve. A line, by definition, is straight. So, through any 2 points, there exists exactly one line. You can try to draw another line through those 2 points, but switching colors, switching from a pen to a pencil is not going to make it a different line. There's only one way to draw a straight line through those 2 points. Anything other than straight is no longer a line. So through any 2 points, there exists exactly one line. Part B, if 2 planes intersect, then their intersection is a blank. So for here, drawing a plane is a little trickier. Might look something kind of like this. So there's one plane, and then another plane would come down. Maybe not be able to be seen for a little bit because it's behind the other one, and something kind of like this. We're talking about basically 2 pieces of paper folded to make an X of some sort. So where do these 2 planes cross? So where does a flat surface cross a vertical surface? Well, right here you can see, and it's not a great drawing, but they're going to cross at this spot right here. And what's the geometric term for this spot? Well, it looks like a line segment. And that's a really good guess, except what we have to keep in mind is that these planes are just a picture of a plane. A plane, by definition, goes on forever in all 4 directions, left, right, forward, and back for the horizontal plane here. Now, we don't draw it that way because we need to contain the plane on our paper to, make it manageable. So technically, this goes on forever, forward and backwards. Well, what do we have in math class that goes on forever in a direction like that? Well, this looks very similar to what we just drew up here. It's a line. So 2 planes intersect. If 2 planes intersect, then their intersection is a line. Now keep in mind, it does say if 2 planes intersect. It would be possible for the planes to not intersect if they were parallel, like the floor and your desk or your table. Those 2 planes would not intersect. But if they do eventually intersect, they would intersect at a line. The third one, through any 3 non-collinear points, there exists exactly what? Well, part A says through any 2 points there exists exactly one line. Part C, we're now talking about 3 points. Non-collinear, so typically I think of them as a triangle. This is no longer a line. We cannot draw a line through those 3 points. And you might think, well, they're 3, they kind of look like a triangle, so maybe there's a triangle that we can draw. But if you think of drawing a triangle, you could draw that triangle, but you could also draw that triangle. Goes through those 3 points. And this one says there exists exactly. This one there exists 2. So maybe it says there exists exactly 2 triangles. But then we could draw another triangle and it could look something like this. And we could play this game for a really long time, drawing triangles. Just because they're in a triangular shape does not mean that's the answer we're looking for. So we have our 3 points. If 2 points make a line, what's the next size up? Maybe the next dimension up from a line is a plane. Through any 3 non-collinear points, there exists exactly 1 plane. Through any 3 non-collinear points, there is exactly 1 plane. Through any 2 points, there exists exactly 1 line. There is that relationship there that when we add the 3rd point, we get an extra dimension from the line to the plane. Now the best thing you can do is memorize these word for word, and maybe make flashcards. You could practice drawing the pictures, but please don't invest too much time into your artwork. More importantly, memorize those postulates.